Good morning to you all. I'm very happy to be here back in Bourgogne. I did work here for a while, and this is the second live program. I did participate in the first live program with Laurent Paris and Pierre Durlet, and it was a pleasure. So I'm here to present the work by three offices, ASCA, EPIS, and Ecological. So we assessed the ecological continuity, restoration in the Seine-Normandy basin. We did this assessment following several years of work. As you can see on this graph, this is a number of ecological continuity projects which have been implemented in this basin throughout the years since 2000. So this is a really old policy. This policy actually started being implemented in 1980, but we can see a great increase in the number of projects in the last 5-7 years. So we have started assessing the implementation of this policy using 7 questions. 7 questions were put to us, which we translated into modules. Some of them were ecological, biological, others were more social assessments, economical assessments, and policies assessments. So I am going to present today the results of the biological efficiency assessment. So to answer these questions, we used one method. The method was to separate the Seine-Normandy basin into 2 areas because they're very different because of the diadromous fish area and the holobiotic species on the right-hand side. That's the Arc Normand and Bassin Seine. And we decided to not focus only on ecological continuity, but always look at the background, look at the habitat and the water quality. As you know, when we restore fishes' freedom of movement, it is to lead them to certain significant areas. So what are the number of obstacles in the Seine-Normandy basin? The 11,700 obstacles were listed. That's 5,000 dams, about 1 meter average, not very high, and the density is about 1 dam every 12 kilometers. So that's 1 every 2 to 3 kilometers on the coasts. In terms of actions, in the last few years, we saw different actions. 380 fish passes have been implemented in the basin, Seine-Normandy. You can see about half of them have been built on 9 rivers, mostly on the Arc Normand area. And we've had other areas for downstream passage of the fishes, 52 of them. And the removal, leveling actions were at the number of 532 over the whole basin. What about the assessment of the effects? We decided to work on 2 scales regarding diadromous fish, and we decided 3 territories would be used. That's Vire, Ornaval, and Touques. The first element we can talk about today is that the ecological continuity actions improved colonization of salmons and the bigger diadromous fishes. They now reproduce over almost 2,000 kilometers of rivers, when back in the days it used to be just few hundred kilometers. Same for the marine lamprey, 735 kilometers, and Alice shad, 240. So great improvement for these species. We could also look at data following the migration of the fishes. So we looked at 6 stations, and when we cumulate the passage of these areas, we can look at 2 species, the salmons and sea trouts in Seine-Normandie. So for salmon, we see an average of 6,000 individuals who passed. And for the trout, this is the most colonized basin by this species. So this is a great success for France and Europe, in fact. So we saw this result, this colonization result was a great success, allowing the fishes to join the spawning grounds. And the actions we implemented to level or remove obstacles helped recreate spawning and reproduction areas. It was also important to us to look at the background, at the situation, because when we look at the number of fishes, we see great differences between the streams. So in Normandy, some rivers are better for the trouts. And the riverbed has a great impact on the species. So one parameter can really change the number of fishes in the Touques. As you can see, they managed to colonize 200 kilometers, and in Brel, 30 kilometers. And some other rivers host more salmons, like Vire and Orne. Another effect is the shape of the riverbed, the morphology. And we can see for marine lamprey, if we see the number of lampreys colonizing streams, we can see a lot more on the Seine streams. And that's because this river is attractive because of the flow, because of the stream. There is low potential in the Seine, however. This species is attracted by hydric flow, and this really is a significant parameter when we analyze the results. So let's look a little bit closer at the Vire River. We used the data from the Biodiversity French Agency, Fishing Agency, Water Agency in Normandy, and Seine-Ormière Association. And you can see in blue, it is the salmon juvenile in the Vire River evolution. And in red, the adult salmon going through the dam, the first dam on the Vire River. And we looked at the evolution following the different actions implemented on this basin, starting in the 80s with the first fish passes. Then they became a bit more sophisticated with basin passes, then hydropower plants, which were at times stopped during downstream passage. And we can see the progression, the changes in the population. We saw 900 salmons colonized. That's a strong increase. Different evolutions were the implemented actions, as I said, fish passes, for example, and removing obstacles and hydropower plants actions. So as we said, these obstacles removal actions took place on major streams. And we see here the indicators in juvenile population with the number of adult passage, and you can see an exponential great progress in the salmon population over 25 years. And we looked at the same data on the Touk River, and this is the evolution of the sea trout population. And we see an increase of the free movement on this axis. More than 80% of the axis is reopened now for sea trouts. We have seen a new basin with a sewage plant in Lisieux and the evolution of the sea trout population when we removed obstacles. And we interpreted the evolution looking at the different plateau effects. We had about 3,000 sea trout per year, and after the actions were implemented, about 5,500 individuals surviving each year. So we increased the survival rate by improving the ammonia level and nitrates. So this was a synergy of the free movement and water quality improvement, which led to these results. In terms of solutions, we can see different solutions for these diadromous fishes migration. So as we can see, improving free movement, improving water quality. We see an improvement in stream habitat, hydrologic background, which could happen in ecological backgrounds, as we know. For example, low flow rate or high flow level in the river can have an impact on the number of individuals in the river.
Then we focused on 7 zooms, so the sand basin for oleobiotic fish. So we don't have diadromous fish, so it is about removals at different levels of the basin in the Haute-Marne, Eure-et-Loire. And we had a follow-up before and after removals, and we have seen fish observation, and the results are that when we restitute a lotic area with whales, we have got different indicators, the species, which like flows or food thanks to invertebrates. And we can see the evolution of the quality of the system. It is a localized effect on this habitat, which are modified. We can see that we have got 3 types of answers. So on the Touk, we have got a progression due to the free movement. Thanks to the quality of water, we have got an effect which increases the stocks. We have got an exponential, a growing effect on the VIR with a synergy of actions, free movement and habitat at the level of axis, and we have got a localized effect on works on a small space with an indicator. On all that, well, we had doubts at the beginning, and we said that fish passes, it was difficult to maintain, it didn't work very well, but clearly today we can say that without the construction of the first fish passes, we couldn't have an answer from the migrating fish. So we have got an increase of this migrating fish, but it is difficult to build, to maintain. So we were asked to look more precisely to the functioning of passes. So we didn't look at all the passes of the basin, but we took the checks made by the police or other management organisms, and in 2016 we realized that 2/3 of the fish passes are functioning, and 95% of works on the big streams are functioning. For the non-functioning part, it means infrastructures which cannot help fish to go through. 0% for devices on big axis and 27% of these devices in Normandy. Which was interesting was this situation in 2016 and conformity with navigable streams. So we have got 40% in 211, and thanks to checks, we arrived at almost 95%. And we can see that in the partially functioning part, efforts of checking on this works, but consuming a lot of ETP, it allowed to have good results. So we were asked a financial analysis in order to see if we were not wasting money. So investment, 71 million euros on 30 years. And if we consider that we have got 20% of fish passes which are not functioning, it is 5.7 million euros which are useless. And when it is not optimized, it is 6.6 million euros. So most of the investments, we have got functional infrastructures. Something that we can add, well, instead of caring about ecological continuity, you should look at the quality of water. But it is not true. So the effort for the quality of water, it is the main investment in comparison to the ecological continuity. And it is supported, so on 5 years, it is 5.6 million euros per water bodies. And in comparison to the other 874 water bodies, so what we remind of our study, it is an efficient environmental policy. It was fruitful with different results. And of course, these results cannot be attributed only to fish passes construction. It is a synergy of actions allowing to get these results. It means that we have to work at the level of territorial scales and focus on the whole synergies. Today, it is obvious that there is an evolution in practices. So we have got removal of dams, instead of deployment of fish passes. It produces significant effects. We are improving the habitat and all the aspects of free movement, and we are aware that some people are against it with the history of these dams, and we need to have a lot of dialogue. To conclude and to finish with one aspect, in parallel of this evaluation assessment, we carried out surveys with the EPIS research firm. So we had a removal of work. So we asked the people what was the difference. So first of all, a new access to the river. The people were able to go close to the river again, and we had a lot of opponents at the beginning. And the second aspect, it was about the sound. So at the beginning, we had the sound of water, and then we had runoff, which was more pleasant. I don't have the possibility to put the sound, but first you will have the water sound with meals, and then a more pleasant noise.
pas si on peut enclencher. Moi, j'ai pas la main pour enclencher. Voilà.
This is the real noise of the river. I thank you for your attention, and you are the judges to decide what is more pleasant.